Welcome back to Arxflix. Today, we're diving into an innovative new paper titled ULIP, Learning a Unified Representation of Language, Images, and Point Clouds for 3D Understanding. This research presents ULIP, a framework that aims to improve 3D understanding by combining the strengths of images, text, and point clouds. The recognition capabilities of current 3D models are limited by the small size of annotated datasets and a predefined set of categories. Unlike their 2D counterparts, 3D models haven't benefited as much from multimodal learning. Inspired by advances in using multimodal data for 2D models, the authors sought to apply similar techniques to 3D models. This could significantly improve 3D recognition, especially under limited data conditions. ULIP stands for Learning a Unified Representation of Language, Images, and Point Clouds. It aims to align features from these three modalities in a single unified space. How does ULIP achieve this? First, ULIP leverages a pre-trained vision language model, like CLIP, that has been trained on large-scale image-text pairs. Then, ULIP aligns the 3D representation space to this pre-trained image-text space using a small number of synthesized triplets. This illustration shows the multimodal pre-training process. ULIP uses a batch of objects represented as triplets comprising an image, text, and point cloud. Contrastive losses are applied to align the 3D feature with its corresponding image and text features. The authors created training triplets from ShapeNet 55, a large public 3D CAD dataset. For each CAD model, a triplet is built with an image, text description, and point cloud. Point clouds are generated by uniformly sampling points from each CAD model. They employ data augmentation techniques like random point drop and scaling. Here's the equation for the 3D representation of a point cloud. Multi-view images are rendered by placing cameras around each object. This results in a comprehensive set of images for each CAD model. The streamlined feature representation is extracted as follows. For text, metadata from ShapeNet 55 is used. Text descriptions are constructed using prompts similar to image text pre-training tasks. The representation is computed using ULIP conducts pre-training to align these triplets in the same feature space. By leveraging pre-trained vision language models, ULIP enhances the 3D understanding of point cloud encoders. Cross-modal contrastive learning is employed to align these triplets. For each object, contrastive loss is applied among each pair of modalities as follows. By combining these losses across all modality pairs, the final loss is defined as ULIP was tested on tasks such as standard 3D classification and zero-shot 3D classification using different 3D backbones. ULIP showed significant improvements in both tasks. On scan object, for example, point MILP improved by approximately 3%. ULIP also outperformed point CLIP by a remarkable 28.8% in zero-shot 3D classification on ModelNet 40. This graph shows the data efficiency comparison. The x-axis indicates the training sample percentage, and the y-axis denotes overall accuracy. Both point MILP and point BERT show considerable improvement when pre-trained with ULIP. Check out these qualitative results for real image-to-point cloud retrieval. Query images from Caltech 1 are used to retrieve point clouds from ModelNet 40, demonstrating ULIP's retrieval ability. ULIP represents a significant step forward in 3D recognition by unifying language, images, and point clouds. It leverages the strengths of pre-trained vision language models and improves representations of 3D backbones. ULIP achieves state-of-the-art performance in both standard and zero-shot 3D classification tasks and offers promising potential for cross-modal applications. That's it for today's video. If you found this summary of ULIP insightful, please like, share, and subscribe. See you next time on Arxflix. Thanks a lot to Element for supporting Arxflix and providing this wonderful voice.